Okay, we're going to start off with the definition. For any two sets A and B, the intersection of A and B symbolized A intersect B. That symbol is the upside down U. If we use the U for union, this is the same symbol, just upside down. We define the intersection. We use a Venn diagram like we did last time. If this is set A and this is set B, the intersection of sets A and B is only the part where they overlap. So only the numbers that are in both set A and set B get put in the intersection. For the union of two sets, we used every number that was in either one. Now for the intersection, we only use the numbers that are in both sets. So let's look at an example of that. Example 1 says, let A equal the set of 1, 2, 3, and 4, and B equals the set of 2, 4, and 6. We want to find the intersection of A and B. So the intersection of A and B is the numbers that are in both set A and set B. So if we look at set A has a 1, but 1 is not in B, so we're not using it in the intersection. It has to be in both sets. 2 is in both sets, so 2 is in the intersection. 3 is not in both sets, but 4 is. And it's the same thing with 6, that's in set B. Since 6 is not in set A, we're not putting it in the intersection. So the intersection of set A and B is only the numbers 2 and 4. Okay, we already talked about the definition of a compound inequality. It's two or more inequalities linked by a connective word, either and or. And last time we talked about or, so this time we're going to talk about and. So we're going to look at the steps for solving a compound inequality with and. First step is to solve the inequalities separately. And then the solution will be all the numbers that satisfy both inequalities. Let's work an example. This will be example 2. X plus 1 is less than or equal to 9, and x minus 2 is greater than or equal to 3. So the first thing we do is just solve these inequalities. If we solve the first inequality, we subtract 1 from both sides to get x is less than or equal to 8. Add 2 to both sides in this inequality to get x by itself. We get x is greater than or equal to 5. Now we're ready to draw our solution. So we're going to graph our solution on a number line. And when we graphed a compound inequality that had the word or, we shaded in both of these inequalities on the same number line. And we will eventually do that in this example, but I think it's easier first to draw these as separate number lines. So we're going to do that, and then we'll be able to look and see where those solutions intersect. So the first number line, if we're graphing x is less than or equal to 8, that means we have a closed circle at 8, and x can be anything less than that. So we shade the left side of 8. And this arrow will go all the way to negative infinity. And we're going to draw a separate number line just right below this one to graph x is greater than or equal to 5. So we're going to have a closed circle at 5, And then x can also be anything greater than that, so we shade the right side of 5 with an arrow going all the way to positive infinity. Okay, this isn't quite our solution. We are going to draw another number line to represent the intersection of these two inequalities. But drawing them separately kind of helps you see where they intersect. And that's going to be this part in the middle. So x is less than or equal to 8. We can use the numbers that are less than or equal to 8 until we get to 5, and then we have to stop because our solution also has to be greater than or equal to 5. So all these numbers over here won't be in our solution because even though they are less than 8, they're not greater than 5. And they have to be both to use them in our solution. Same thing with these numbers that are past 8 over here. Even though they are greater than or equal to 5, they're not also less than 8. So we can't use them in our solution. We can only use the numbers that satisfy both inequalities. So our solution, when we graph it on a number line, we'll have a closed circle at 5, a closed circle at 8, and only shade the line in between. So if we write this as an interval, we have a square bracket, 5 to 8, square bracket on the other side as well. Let's look at another example. This will be example 3. Okay, we have negative 3x minus 2 is greater than 5, and 5x minus 1 is less than or equal to negative 21. We're going to solve both of these inequalities separately. So add 2 to both sides. We get negative 3x is greater than 7. Divide both sides by negative 3. We're left with x on the left side. We divided by a negative, so our sign has to flip. 7 divided by negative 3 is going to give us a decimal. Let's just leave it as negative 7/3. Okay, solve the other inequality. We're going to add 1 to both sides to get 5x is less than or equal to negative 20. Divide both sides by 5. We get x is less than or equal to negative 4. Okay, let's draw our two separate number lines. Just looking at x is less than negative 7/3. We have an open circle at negative 7/3, and x can be anything less than that, so we shade the left side all the way to negative infinity. Our other number line, I want to be able to plot -4 on this number line correctly in relation to -7/3. So like, I don't know, is -4 less than -7/3? Is -4 bigger than -7/3? If you don't really know, just plug that into your calculator. -7 divided by 3 is about -2 1/3. And so -4 is less than that. So -4 is going to be plotted about there with a closed circle because it's less than or equal to -4. And x is less than -4 as well. So we shade the left side going all the way to -infinity. So to find our solution, we just see which parts of our line are shaded on both of these graphs. And that's from -4 and to the left. So this part of this graph that is shaded, even though it is less than -7/3, so it makes sense from this inequality, it's not less than or equal to -4 as well. So we can't include it in our solution. It has to satisfy both of our inequalities. So our solution is just going to be a closed circle at -4 and shade all the numbers less than that all the way to -infinity. So I don't want this to be confusing. When I'm drawing these two graphs, I'm still working to find my solution. And I want to make sure that when I plot these numbers, I plot them correctly in relation to each other. When I plotted this one, I know I put the -4 over here instead of lining it up here. But at this point, I'm just drawing my solution graph. I don't really care about these two anymore. So these two graphs, you want to be careful about where you put your numbers. On this one, when you're just drawing your solution, it doesn't have to match the other two that you did, really. I don't know if that was confusing for you, but hopefully that cleared it up. Okay, so our interval notation for this solution, we've got all the way from -infinity up to -4, including -4. So -infinity to -4 with a square bracket on -4. Okay, we got one more example. This will be example 4. X plus 2 is less than 5, and x minus 10 is greater than 2. Solve both of these inequalities. So we're going to subtract 2 from both sides to get x is less than 3. Add 10 to both sides in this inequality to get x is greater than 12. All right, let's draw our two number lines. We've got x is less than 3, so an open circle at 3 X is anything less than that, so we shade the left side with an arrow pointing towards negative infinity. For our other number line, X is greater than 12. So we have an open circle at 12. X is anything greater than that, so we shade the right side with an arrow pointing towards positive infinity. Now, we're looking for parts of these lines that match. There's not any numbers on these number lines that match. So we've got this part of our line shaded on the top one. It's not shaded on the bottom one. And then same thing over here, the bottom one is shaded, but the top one is not. There's no overlapping parts of these number lines. And if you think about it, that should make sense because there's no number that can be less than 3 and greater than 12 at the same time. So if we were to draw our solution and graph it on a number line, we can't do anything. You can't even really plot any numbers. So our solution is an empty number line. And we can't write an interval as our solution. All we can really write is this symbol, 0 with a line crossed through it. That means the empty set. So it's a set with no numbers in it. Okay, that's all for notes. I haven't posted the assignment on Classroom yet, so if you guys will just give me a few minutes, I'll get that posted, and then you guys can get started.